So we're going to do what's inside the parentheses first, and we're going to kind of go left to right with that division before subtraction. So inside the parentheses there, I have 6 divided by 3 is 2. Minus 2 is going to be 0. So I get, 2 minus 2, which will be 0. And you don't have to write all these steps. I'm just trying to get you to see where this is all coming from. Okay. Now, every once in a while, I see someone say, oh, we're multiplying by 0, so it's got to all be 0. But that's just that one little part of this. So if I look at the problem now, I'm going to do exponents next. So I'm going to do 6 to the second power next, which is 36. Okay, so I did the exponents now. Now I have to go through and do all the multiplication and division. When I do that from left to right. So when I do the multiplication and division, I'm going to do this division. I'm going to do this multiplication, and this is actually multiplication too, because it's 2 times 0.
Right.
It's like magic.
You should go like this, stand back, and go.
Yeah. All right, so 36 divided by 2 gives me 18. 3 times 2 is our 6, and that says to subtract that. And then 2 times 0 is 0. So those of you guys who said 12 are correct. Now if you didn't get 12, that means you entered something into your calculator wrong. And you have to figure out what you're doing wrong if that's the case. So like, you know, I don't want you to have operator error in your calculator because obviously it's supposed to be a tool, and if it's just like confusing you, that's a little bit of an issue. So we should get 12. You do not need to show all those steps. You have to make sure you know how to enter it. So what we're going to do now today, so that's order of operations. Pretty like, it might even take you back to pre-algebra, or like even like a 6th grade math class or something, not trying to insult your intelligence, but it's something we forget about. So that's why we warmed up with that. The next thing we're going to do is talk about evaluating expressions, and that's when we actually take the values we know and we substitute them in. So, and then we follow the order of operations. So, they're doing tree work again.
I don't know, but it sounded like planes were flying over before.
I know. We thought, well, I was in Mr. Donahue's room talking to him at lunch, and like we thought it was thunder, and I think it was like, it sounded like a plane like then, but I don't even know.
But it sounded like they were like
right over, like,
circling.
yeah.
Because it wasn't just Mr. Twice.
No.
Russians are coming.
The Russians.
That's what she meant, the Russians. All right.
So, blocker communications.
Okay. So guys, evaluating expressions, they give us these values for A, C, and E. So what we're going to do with that is we're going to substitute those values, like put those values in. I know. We're going to substitute those values for the variables. So what that means, we'll put those values in. Really be careful, especially when we have like double signs, when there's like a negative, just be really careful with that. Then we're going to follow the order of operations and basically use our calculator to find the answer. They say evaluate just means find the answer, like what does it equal? Yeah, it is. me, I'm just gonna melt down on the board, just gonna lose my mind. It's not working the way I want. Alright. Okay, so what we're gonna do with this is we have to be really careful with signs here. So notice it says 5 minus a plus c. So we're gonna take these values and substitute them in. But we have to be careful because we're subtracting a, and a actually happens to be negative. So you have to be really careful with signs. So 5 minus a is a negative 5. So a lot of times when it's a negative number, I'll use parentheses so that we can kind of see what's going on there, so that it doesn't just look like a really long subtraction. And then plus c. So I'm putting these values in where they show up. Now what happens when we have two negatives like that? Becomes a positive. Again, feel free to use your calculator as much as you're comfortable, but if you can do this without having to grab it, it's up to you guys. I don't, obviously I'm not judging you for using your calculator, it's fine. I just want you guys to get it right. So we end up adding those and we end up with 17. Alright, so this next one, what are the 2 and c doing to each other? What are 2 and c doing to each other there? What math are they doing? It's multiplication. So this 7 is going to go here, but it doesn't become 27. Every once in a while, I have a student write that. They just make that the second digit. It's saying 2 times 7. So if you want to put a dot there, you want to use parentheses. So 2c becomes 2 times 7 minus the parentheses. A is negative 5. So this value. So I substituted everything in. And again, I know some of you guys, this is old stuff, and you're like, holy cow, this was so easy. Why are we taking our time with this? I just need everybody to be on the same page, because not everyone feels the same way about stuff like this. Can you close that up? What's 2 times 7? 14. Minus, I'm going to do what's inside the parentheses first, but again, if you use your calculator, that's fine as well. I'm subtracting these, down 5, down 3 more. This is down to negative 8. Go, yay! All right. And then the 2 negatives become positive, so 14 plus 8, and so that'll give you 22. All right. I know. All right. So our next one here, we're going to take and substitute all 3 values in now. So negative 3. Now this time I'm using parentheses because it's a negative 5, but they're still being multiplied. So negative 3 times the negative 5 minus c, which c is 7, minus e, which is a negative 2.1. So throw in some decimals in there. So we're going to evaluate that now. Let's find an answer. So to multiply first. And so that would be a positive 15. And then this becomes plus 2.1. So that's 8 plus 2.1. I know. And then this becomes 10.1. I did realize, I think I left this on overnight, so maybe it's mad at me now.
It didn't get enough sleep.
Yeah, well, we're tired. Because we had those parent meeting things, and then we went to Powder Puff, so I just forgot and unplugged my computer and left. And I didn't turn this off.
Good job.
I know. Fail.
Bad parents.
bad parenting for my computer.
Yeah.
That's why it's being defiant now. It's like an overtired toddler. My dogs have been acting that they're being like they're being naughty. Well, May's our bigger dog. She like when she's mad that we haven't been home, like she'll carry her shoes around the house and move them someplace else. So she I'll go look and like my shoe, like I have one shoe sitting in my bedroom and I'm like, where is the other? And it'll be like down in the basement. She had moved it down there. She doesn't chew on it. She just walks it down there and sets it down and then so she steals our stuff. Like she doesn't chew anything. She just
It's a ferret.
Ferrets hide at things like I remember when my friend had a ferret when I was in high school and she used to hide people's car keys. The ferret would come take the car keys off the counter and hide them in the couch. And you go to leave and your keys would be gone. Ferrets are sneaky.
I guess we're staying here tonight.
Tear up the couch.
Yeah.
We're also gonna ferret to get intestinal blockages really
Because
easily. Because they're so small.
Cat knows something about intestinal blockages, right? Oh yeah. Her dog eats everything. I didn't mean cat herself. Cat, stop eating things. All right. Do you guys know what a coefficient is? And you probably forgot because we use this word a lot. I mean, we've actually seen coefficients today. Yeah, what do you think?
It's the number that is being multiplied by an exponent.
Not by an exponent. Doesn't need an exponent. So in number 7, what's the coefficient? It's the number in front of the variable. So it's the number being multiplied to a variable. So it's the value multiplied to a variable. So I'll show you guys what I mean. So in 4x to the second power, 4 would be called the coefficient. The x would be called either the variable or the base, and then 2 would be our exponent, but right now we really care about that coefficient, the number in the front. The reason for that is when we combine like terms, we're going to add and subtract the coefficients of like terms. That's a really big U. So that might ask you the question then, what are like terms? Reminder that like terms, they have the same variable and the same exponent, or they have no variable at all. So like terms, they're like that they have the same letter that we're working with, the same variable. Whoa. Like terms have the same variables, or they have no variable at all, or they have the same exponent on that variable. Once we see it, I think it'll kind of come back to you guys on what is like terms and what aren't. So we can combine like terms only, and we can only put them together if they're like terms. So like in this first example here, we'll do these 2 examples and then we're going to take a whiteboard break. We're going to do these 2 examples and then if you want to try it, so make it down here. No, it's okay. Okay. Okay, thank you. All right, bye. like terms. What do you guys want to put together in example 1? The 17a and the 4a. So 17a and 4a are going to go together. What we do is we add those coefficients, so the 17 plus 4, and then you just leave the variable as it is. So you're not going to call it like a to the second. It's just going to be 17a, 4a is going to be 21a, right? So you just add those like terms. And then the 9 and -3 are also like terms, so they're just numbers. They're, you know, they both don't have a variable, so they're like for that reason. So the positive 9, but then it's a -3. So positive 9 minus 3 is going to be just 6. What kind of 6, Will?
Positive.
Positive. So I'm going to write plus 6. I sort of going to write plus 6, or just squiggles. So I write plus 6. Now, are these two like terms? No, the one has an A, the one doesn't. The 21 has A, 6 doesn't. So this would just be our simplified version of this answer. Now, tomorrow when we start, we're going to add to this, like we're going to take this and make it an equation. Right now, all we're doing is simplifying. Just that we're comfortable with like rewriting these with values that, just like in simplest form. All right. What do you guys want to put together in example 2? Okay. Yeah. So now this time, the c squareds are like terms. They have the same variable and the same exponent on it. And notice when I circled it, I circled the 12, but I also circled the -8. That sign in front of that 8 is that number's sign. So it's the value is a -8. So 12 minus 8 is going to be what? 4, and then we just write c to the second. And then I have 5c, and then how many c's here?
1.
Right, so if you see a variable without a coefficient, it's really like a 1. So this is 5c and 1c, so that's going to be 5 plus 1 is going to be 6c. And then those aren't like terms, so we just stop there. It sounds like the majority of you guys are pretty good with that, just based off of just like you guys just talking to me about it. I do want to still take a quick break with whiteboards. So if you guys want to go back and grab a whiteboard, if you want like just the Kleenex off my desk to erase, you're welcome to do that. So are you heard me odds for the whole thing? I know if that's your idea to be here, that's don't lose that. Kat, you better not be complaining about being warm, because Paige was just in here complaining she was cold because you stole her sweatshirt.
Okay, I asked her like 3 times if she wanted it because I want to like. I feel bad now, so I want.
She was just in like here a minute ago, Paige.
We were like passing. We were passing. I was passing home, and she's like, "We got my sweatshirt." I'm like, "We're literally like walking down the hallway in opposite directions."
Say nice.
I am, like, this is the first day I've been like.
Yeah, no, you've said that a couple of times. It like makes me worried you're sick.
So it looks like
I'm not old.
Deal with it.
Maybe I'm sick then.
Yeah. No, don't be.
Yeah, no. I said like this weekend when I was all stressed out about all of the funny stuff coming up, I'm like, what if I just woke up and I like had the coronavirus in the morning, like on like Monday morning, like sorry
Guess I'm
guys.
not going to school.
Yeah.
Sorry.
Good luck with the homecoming.
Fly by the seat of your pants.
All right.
Let Jesus take the wheel.
Jesus.
Can't take that wheel.
Alright, try this one. So evaluate this. So this is kind of where we're substituting those values in and then telling me what the output is. Like once we put the X and Y in there. Careful on signs and stuff like that. Yep. Now, just careful, this is being multiplied. assume something, there's some math going on there. What's that?
I think that's cool.
Yeah, you're good. Yes, that's better. Thank you. Yes, thank you. Yes. Yes. Ryan, do you catch yourself?
Yeah.
Yes, sir. Good work. Yes. All right. I see a few of you guys waiting, so I just want to make sure we're all kind of on the same page with this. What we do is we just put that value in. So it's 3 times that x, so it'll be 3 times -2, and then minus y, which is 6. So we put those values in. Now 3 times -2, when I multiply that, it's a -6. Then I get -6. Careful, it's really quick, like you think like 2 negatives, it's gonna be like maybe cancels or something like that, but it gets more and more negative. You think about like maybe, you know, football idea, you lose 6 yards, you lose more, 6 more, you lost 12. So that would be our final answer there. Okay? Let's try another one with the evaluate. I might just, let's see. I might just change up the answers here, or change up the ifs then. Alright, so let's evaluate this time if x is 5 and y is -4. So same expression. Let's evaluate those values instead. I have to do the math in my head first. Yeah, you're good. Yeah. Careful. Do you notice it's minus y? So it should be kind of, yeah. There's like a double negative there. You're good, Jen. Yes, good job. Thank you.
Yes, yes.
Yeah, that slight, that minus y is like a tricky one with that negative. So this one's kind of a weird one. You have to do your multiplication first before you can do that addition. So I think you add it first, so do those 2 first. Good work, thank you. So in this case, we're multiplying the 3 times 5 together first. We get 15 there. And then I have minus and -4, which really becomes just +4. So that becomes 19. So you have to really be careful, especially with those double signs. Alright, so this should be reviewed, but at the same time, it's not like you guys were doing this in summer, you know, hanging out with your friends, like evaluating equations. So it's totally okay if we had to review this and you're a little bit rusty. I'm going to still move on to the combining like terms, just to make sure we got that, and then we'll flip to the back side of our notes and work through that. So I want you to simplify these by combining like terms. Okay, so simplify this by combining your like terms. And it doesn't matter what order you put it in when it's done. Jenny, you're good. Yep. Good. Good work. Yes. You can have a book with me? Yeah. Yeah, that's what I was asking. Just open the shop for your house. I was just trying to figure out what time to do. I think people are going after school now that soccer is canceled. So, yeah, I think we have a few sick people on our team. So I think we only had like 2 subs before people were sick. So like the people means I don't think we had enough guys to play. And if it helps to visually like circle things, that's probably not a bad idea. And the order you do this in doesn't matter. So 7 minus 5 is this 2. And 3x and 2x is going to be 3 and 2 is going to be 5x. And you just need to stop there. You can't go any further because we don't know what x is in this case. And if you had 5x plus 2, it's the same thing. The order we add in doesn't matter, so it doesn't really matter if it's first or last or whatever. Okay. Let's do another simplifying one. Try a better one. Yes. Sometimes I don't think about what the answer is before I start doing it. We'll check something on that. I think you might be missing something. Yeah, you're good. Unless I can't see it from far away. Yeah.
Oh,
Yes.
wow.
Thank you.
I forgot the sign.
That's kind of a, big deal.
That's not a big deal.
What if it was your bank account?
I'm the same boy from last
That's
time.
okay.
Yes.
I really have $7.
$7 billion.
No. Yes. I just said 7.
Million, billion.
So you're really using it to know. Ooh, Yvonne. All right, Jeff.
All right, let's try one more. Good job. Yeah.
Oh, it's
Choose a little trickster.
Yeah, we'll check star. Yes. Kat, did your parents tell you that I was sitting by them when you and your sister got flagged? I was like, whose children are those on the microphone? Not quite.
I don't remember that.
You blacked it out. Yes.
Oh, she threw a ball at me.
I said, who got the flag of it when I think Mr. Huckle's like, I think it was Lizzie 'cause she's the one who spiked Kat with the ball.
No, I probably deserve the flag first. That's okay.
Wait, who won?
The juniors.
Oh,
Yeah.
wow.
They're pretty, Becca is, like, she should probably play football, like, yes. Tough cookie. Alright, yes. The senior class is not known for the number of, what? Yeah, he keeps showing me over and over again. I keep telling him yes. He apparently needs a lot of reassurance that he's doing things right. All right.
He's a little slow.
You never know.
I did used to do this years ago to me. So like I feel like somebody else he keeps showing me the answer over and over again. I keep saying yes.
Yeah, me a review it and then what's the same?
Yeah, I forget that I had seen it before, and so like just needs some self assurance. So. All right.
No.
So this part of it.
Here you go. Yes.
This is Don who thinks I'm so smart. She's
Wow.
So in this case, we have 1 minus 4 plus 3. Hopefully some of you guys realize you can rearrange this. I like doing 1 plus 3 first, and that's 4n. And then I subtract 4n. Now when I take something away from itself, it just becomes 0. So that part cancels out. So you don't want any n, or you put like 0n. It's kind of a little bit confusing in that case, so we're really just left with 5 here. You guys can clean up your boards. We're gonna flip to the back side of our notes when we're done there with picking them up.
Oh, I can clean up.
Instead we have no jab.
Does anyone remember the Barney next
Whoa.
Barney wasn't your guys' area, was it?
Yes, it was.
Yeah.
Are
Yeah.
you Barney?
Yeah.
What's
Because we had two twins, and one of them, when she thought she was so cute, she'd sing me this song. And like, and you couldn't stop her, like, she was like, it was like, she'd sing it, and then she'd go, I love you, you love me, I love you. That's a, what, how does it go?
I don't know. I have the cleanup song in my head.
What?
I love you love me, very happy, and the
What?
great big hug,
And
kiss
a
for
kiss
you.
you, won't you say you love me too? And then all of a sudden she'd go, I like you, like another bitch off. I listened to it the second time, and standing there. It was so cute.
Okay.
Terrified.
So, if you guys flip your page over, we're going to talk about the distributive property on the back side. And we'll do some of these problems. We won't do them all. I'll throw in a few fraction there just to confuse you. But I will do a few fraction down there just so you're not afraid when those come up. But distributive property, I think you guys know this. It's and I'll show you guys just a quick example of what I mean. So if I have like 3, whoa, yikes. Math, 3. And then I have like 2x minus 5. This is an example of distributive property. What do we do with that 3? Yeah, they both get that 3 on the outside. So it gets distributed in either by multiplication or it could be division. There can be distributive property with division we'll talk about as well. So every term gets that multiplied or divided to it. Or that extra long JD thing there. So every term is either multiplied by, so in this case I'd be multiplying by 3, so this would end up being 6x minus 15. 3 times 2, and then 3 times 5. And then we know now that those aren't like terms, so we just stop there. We just write it as 6x minus 15. So when we combine these two ideas together, we're going to do distributive property first, then we're going to combine like terms. So that's kind of the order we do things in, because it's multiplication, division before addition and subtraction. Distribute, and then we'll combine our like terms from there. So like on example 3 there, start by distributing first at 4. Now when it gets distributed, it's only distributed to the parentheses. So whatever's inside the parentheses are going to get those at 4. So in this case, we're going to distribute this 4 into both of those terms there, but not to the other little a, because that's not part of the parentheses. So 4 times a, we're multiplying this. This becomes 4a. 4 times a negative 3, and we're multiplying, so a negative 12. And then that plus a just comes down. So we started by distributing first. And now we need to combine our like terms. So I'm going to put the 4a and this 1a together. And we'll end up with 5a. And then the minus 12 kind of stands on its own because it's not a like term with the other piece. And like I said, this is not something new to you guys. I know some of you guys know this and you're like, this is really boring or it's not tough for me, but not everyone's in that same spot. Or like, I just want to make sure I don't assume that everybody is comfortable with this again, because it could have been that you guys haven't had this since like last January, especially with the way our schedule runs now. So it might have been, you know, a big chunk of time since the last time you've seen this. What's being distributed in number 4? The 3. The 3 is going to go here. How about this second set of parentheses? Very good. Like a negative 1 is being distributed there. So it's like a negative 1 is being distributed in, because that minus sign tells us kind of like change that sign. So that negative is the same thing as a negative 1. So we have that. So it's like a negative 1 being distributed. That's helpful if you need to write that down. So 3 times 2x is going to be 6x. 3 times negative 1 is just going to be a negative 3. Then negative 1 times 5 is just going to be a negative 5. And then negative is going to become a plus 6x. So we started by distributing first. And now we can combine some like terms. So this 6x and this 6x go together. What do we get? 12x. They're both positive. The negative 3, negative 5 is going to be negative 8. And that's all we do because we can't combine those because they're not like terms. All right. There's a few kind of weird ones coming up here, so I just want to make sure we're okay with them. Why is number 5 even in this section?
Because they're all divided by 3.
Yeah, so number 5 is technically distributive property, but with division. So this 3 is going to be distributed to all the terms. So this one's just another version, except this is division. So I'm going to take this, and then I'm going to divide all of those by 3. So it is still distributive property, it's a different form of it. So I'm dividing everything by 3. So 12x divided by 3 would be 4x. Negative 3y divided by 3 is going to be negative y or negative 1y, either one. And then 6 divided by 3 is going to be 2. And then these aren't like terms, so we stop here because they're 2 different variables. One doesn't have a variable at all. Okay. All right, let's go down to number 7. We'll talk about one of the fraction problems then before we go. So number 7 technically is a distributive property. There's nothing being distributed, but we're still combining our like terms. So if we skip over distributive property, we don't have to worry about that. We're just going to combine like terms here. What do you guys want to put together in number 7? So I heard 6c and negative c, and this is like a negative 1c, right? Are you sure? You said negative 5c.
I said,
Oh, I heard negative, sorry. 6 minus 1 should be 5c, positive. And so this is kind of similar to the last one we did on our whiteboard. We have 3 different terms that are alike. This is 1 minus 5 plus 7. Now, with addition and subtraction, you can kind of be like go in the order that makes sense to you as long as you keep the signs in the right place. So 1 and 7 is 8, minus 5 would be 3, it'd be a positive 3a. All right. And then those aren't like terms, so we'd stop there. All right, let's just finish up with example 8. Doing one fraction problem is probably fine. Especially since we've talked about fractions more than you probably have in years past or have it for a while. We're distributing this 3/4 in. We're multiplying by 3/4. If you want to, it is perfectly fine to grab your calculator at this point. 3/4 times 1/3 x, you're gonna realize it's a pretty nice fraction. 3/4 times 1/3, those 3's are gonna cancel. And I just multiply that, and that just becomes its coefficient. So it's gonna be 1/4 x. Because the 3's would cancel. Then here, this is like 8/1. So 3/4 times 8 is gonna end up being just 6. Are you guys getting that with your calculator? So don't let fractions freak you out, especially now that hopefully you guys are getting better with dealing with fractions on your calculator. It's just something that I don't want you guys to see a fraction problem and kind of freak out. Okay? When we finish up with 6, so we have plenty of time now that I look at it. Distribute. Obviously, I'd love if no one has to grab their calculator on this, but I'm not judging at all. But 6 times 1/3, so I'm taking 1/3 of 6. What do we get? 2. 1/3 of 6 is just 2. And 6 times 1 is just 6, so just plus 6. And again, we just stop there for right now. And this might be like bothersome to you. Next section, we'll start solving these. But right now, we're just simplifying them. Okay? So I'm going to give you guys your worksheet. It's a worksheet that's different than other ones we've had, just because this is kind of, like I said, like a precursor to what we're actually doing out of the book. It's a little on the long side. I'm fine with you guys just doing odds. You probably will still finish. But I know, like with this week, there's a lot going on. So try to give you guys that time, and you guys do a good job of using your time wisely. And then you won't have to have homework. Let me grab this. So odds on the front and the back. So like basically the left-hand side of the paper. You shouldn't have to look very hard for it. So basically the left-hand side on both front and back.